Right, does this work? Does this work? Hello, hello, hello. Right, does this work? Yes, yes it does. A little bit quiet, but it should be fine. Yeah, so I had this funny thing earlier. Couldn't get my head around something that I thought was quite simple. And so I went for a walk and tried to, you know, live my life a little bit. Went to the pub, had a restaurant meal, and when I was at the restaurant, I just decided to try and like formalize it a bit. You know, it still got me. It really still got me, and I don't know why. And that's what I'm scared of. I feel like I'm stumbling on something that maybe I'm miss or underestimating. So I'll just show you because it's kind of nice to go through it anyway. Um, and I'll put it on the screen as well. But so I was yeah, just trying to kind of come up with some ideas around the fundamental function, and like R stands for range, and A is the alphabet letters, or the number, the length of the alphabet, minus the input. So it should be as simple as that, right? But I don't know how much you can see. You probably can't see much. It doesn't really matter because I'll show you anyway. But um, I put the alphabet out here, and I kind of put like a set so you could see, you know, the length and the L and the range. And where L is up to F, you know, the shell F. Now, if the input is 5, I do 26 minus 5, that equals 21, so the range is 21. Okay, that sounds good. That means that the length is the sorry, the whatever L is equal to this set 0 to 5. That's 6 letters. And then therefore the length of L is 6, right? Now I realize that I've got to like integrate a little bit because I've got to do my little for loop. So I start with n equals 1, and it goes to R, and then for each loop I'm appending R. Well, that can't be right. So then I move on. I don't think I'll go through too much more, but essentially I get to the point where I figured out maybe it looks a bit like this, and I thought that's very complex. So I'll write this one out on OneNote, and it's funny. I've been doing coding for what 15 years or something now. Must be. No. Yeah, 15 years. Damn. And I don't think I've had something like this before. Maybe that's a lie. Maybe I haven't. And when I realize it, I'll be like, oh, I'm an idiot. But for now, a bit strange that I was struggling with it. So let's get back onto it then. Make sure I'm not muted. Great. So we're still on 18, right? Just because I can't bother to do the Duolingo stuff again, let me just try and put this formula down. So I want to know if I have the alphabet, and this is a set, right? And this set is going to have, you know, A through to let's make that a bit bigger. A through to Z, right? Okay. And so let's define L as the kind of known values, or let's do it K as known values. And the known values are what were they again? They are S, P, D, and F. Okay, so I just yeah, let me just put a little line up here, and I'll put a little note. A is equal to alphabet, and K is equal to the known shell values. You know, known values. By shell, I'm talking about the electron shells. Okay, so the the input, which I call I, can of course range from, 0, so no entry, to 0 to 26. Okay. So I stands for the input. Input of the n, basically. I is the input of the n, so maybe we should call this n, right? Let's call this n, where n is the what did you call it? N is the principal quantum number. Okay. So let's change this n and make sure we don't think it's a derivative. Is the input or the principal quantum number. Whoa, quantum number. Okay. So looking good so far. Now we need some lengths as well. So I suppose we've got the, and I'll denote it like this. Or maybe I should just do the. Yeah, let's just do it full hand, right? The length of A is of course equal to 26. Yeah. Where the base is 0, so that's 0, 1, 2, 3, 4. So the last index would be 25, but there are 26 characters in the alphabet. Great. And the length of K is equal to 1, 2, 3, 4. Okay. Right. And now n is a variable, so that can stay as it is. And my equation says, let's put this up here. My equation says, let's put R equals range. So keep that in mind for a second. My equation says the range that I want to loop through is the original set. So the original set is K, all the way up until you put in the number 0, 1, 2, 3, 5, because there's 4 elements in the array. So I want to know, if I put in 5, I want to have a G appear, right? We're still talking about the last one. If you don't know what I'm talking about, just go back to the last video, basically. So I want the original set, K, and then I want to append to that set the integral from. So here's the thing. I'm going to use the syntax I for index of the integral. So let's say I equals 1, and I'll show you why that makes sense, to A minus K, because A minus K is 26 letters. Well, I already know K of them, or length of K of them, and so if I were to put in the number 5, then I want to start from 1 and go through to A minus K. Okay, and let me put that as a variable as well, just to save us time. I'm going to say that is the leftovers. So we'll just call that, I don't know, this thing, whatever this is. Leftovers, which is equal to A minus K. I don't know if this is right. I'm just going through what I went through at the pub, right? And so this would be, this is how many iterations I want to do to add to this k, this original thing, right? So I want to do it to this. So for every loop, I want to go and fetch from the alphabet. Now I'm going to use this notation to get into the index of that alphabet, let's say, or an element in it. And I want to get the length of k, because I need to offset this current set already. So this is the length of k. Let me just put a little gap here because you'll see why. Length of k. And then I want to do -1. And the reason I want to do -1 is because the length of k is 4, but it's base 0. So I need to make sure that I'm going into the index at 3, which would take me to the letter F, right? And then, and I've just seen the problem, and then I was going to say, and I'll +1, or in fact I, because I is the kind of the starting index for my iteration, and then I would close this off, right? Like this. Now, one more problem here is obviously BODMAS. I need this to be at the end, and BODMAS is S is the end one, so I need this to happen first, right? So there's my equation so far. This doesn't work, and I've only just realized it now, which is really interesting. Of course, we don't want to know the length of k here because k is not equivalent to the position of f. So we need to know the index of a, where f is, and so we actually need to know where f is. So let me just move this all down like so, and we're going to put f is equal to f is going to be equal to 5, because 5 is the position or index of the letter F. Let's just make that clear. No, that's fine. 5, where I'll put this over here. F is the index of F in the alphabet. Whew, okay, right. So we've got a couple of variables now, and so I think I see where I went wrong here. So with this given, I need actually it to be not the length of k, but I need f. So it's going to be f. And because that's the index, I'm already at the index. I don't need to -1 anymore. So I'm going to put this one back over here. And then of course I don't need these brackets anymore either, because there's no BODMAS happening. So I'm going to put that back over here. Now it's looking a bit more easy. So let's just go over it again. The range of iterations, or the full set, is going to be the set of k, which is the ones that we know, and then on top of that, like appending, like in Python append, there'll be an integral or for loop. I don't know what the symbol is, so I just use the integral because I know roughly, it's like finite kind of things, right? So I'll go from the first loop, and I put 1 because I always want to add 1 to the current index, all the way to the leftovers, which is a minus k, which is, well, actually, it's not, is it? It's length of a minus length of k, right? Which annoyingly goes off the screen, but it is length of A is 26 minus 26 minus 1, 2, 3, 4, which of course leaves us with 22. Okay, so we're going to actually be iterating to 22. So let's just fill these details out now that we've got that function. So here's the actual here's the real thing here. So it's going to be R. That's a bad color. Let's do a different color. That's a bad color. Let's do that one. Yes. R is equal to the set of k, and the integral is going to be added from I, which is the index of that integral, all the way to 22. And then we want to access where so f, which is going to be the index of f, which is going to be 5, and so let's just take that out for a second. It's going to be 5 plus 1 in this case, because we're on the first one. Let's go step 1. Okay, and then of course we close this set off. Okay, and I think this is still wrong, because if my input is 1 and we do this, so this is going to be 6, and this is going to go 22 times. Well, 6 plus 22 is not 26. And I think I had this problem before. So this is where my confidence zooms away. So now I need to figure out what the fuck is going wrong. So this I 22 26 minus 4 and it's 5. It's this 22 comes from the length of A, 26 minus the length of K, but it's not. It's minus F. Okay, I see. So it's minus F here, which is of course not that, but in fact this. So it's actually 21 now, and so this becomes 21. Okay, so I equals 1 to 21, and 21 plus 6 is still not 26, right? And I think that's because we've offset by 1 here. Now, if I were to do this at 27, even if I did that like minus 1, I would still be 1 too many because I've started at 1, right? So I do need to offset by this one. So let's add to this equation now. Where f plus I is the input, so that's 1 at the moment, and then we do minus 1, and then 1 for this offset, and then minus 1 for the fact that we're doing an index rather than 26, right? Minus 1. Okay. Now the thing is, we're doing 21 loops. So if we have 5 and do 21 loops, 1 to 21. If we have 5. So this 21, okay. So if you have 5 as the input and it loops 21 times, 5 plus 21 equals 26. That sounds good. Now what if we did the input of 1? 1 plus... but this is a problem because now... so maybe there's a fallacy in the... Because what I was going to say is, the problem is, this can't be 26 because we've already got k, the set k, right? So this this is going to have 30 characters in it. But here's the thing. I wonder if so it's not ever going to be a as in 26. So it's not this. It's not the length of a. It's the length of a minus f. 21. But then it's 21 minus the number that we've put in for I, so minus n, right? And this minus n. Okay, so that makes sense. So let's just think of this again. So now let's imagine n is let's imagine n is... Can you see that? Let me just double check. Oh, can you see it? Kind of. Let me see if I can zoom in a little bit better. Okay, maybe that's fine. Yeah. Well, then I can't see. Okay, let me try this one over here. Yeah. So let's imagine that n is equal to 1, right? This is the actual input into it, and we are on loop 1, so it's going to be 21 minus 1 equals 20, and then it's from so then I've got to do I've already got k, which the length of k, which is 4. I've already got 4 in my set, plus 20 which is not 25. And it's not 21 either. Not 22. Okay, I don't want to lose this. Let me just have a sip again. You see how it's oddly complex? An oddly complex challenge. I did not expect this. I'm just going to take my jumper off a bit hot. Okay. Let's try this again. So now we're minusing n, which I think makes sense. The input is 1, but we've also already got k sets. 21 is already taken. It's not. It's because we're traversing the alphabet, but we also need to. It's the alphabet minus f, and it's also. No, I think that's it, isn't it? So if we started from like an iteration, and we've got 21 to go through because we've already got 5 in the array, up to f, then we'd want. Let me just get this out again. We'd go. It's going to be skip the f, which is going to be 5. Then we're going to plus I, the index, which is going to give us 6, which will give us g. And then we're going to do this 20 times. So if I go to, yeah, that's it. That's actually it. And that's our set. Holy shit. So now if I go, okay, well hang on, I think I just solved it. Ay, ay, ay. So if we do n equals 26, then then I would be 1 to 21 minus, no, so n must take off. See, there's another part of this. Okay, that's interesting. So n must minus the 5 already. Maybe that tidies things up. N equals 26 minus f, which would equal 21. And then we're back. And then we're back to minusing n, which would be no. Focus. So okay. Whew, it's making me hot. So let's look back at this again. This has to be wrong. This can't be right. So we've got the set 5. So we have to start. The index will be 5, like this. Maybe this will make things easier. I equals 5, or I equals f, which of course therefore means 5 plus f plus 1. Okay. F plus 1, which therefore equals 6. That means that I'm going to start my iteration at 6, and I'm going to put it to, it's got to be 20. No, it's got to be 21. So it has to be 21. It has to be that. Yep, that's correct. That must be 21. And so yeah, and if it has to be 21, then n, let's say n is, you see, because I'm not even trying to do n equals 0 yet. Let's add that after. So let's try this one more time. So, no, do I add it now or after? Do I add it now or after? Maybe I should try this with 0 first. So in this case, it would be, I'm not always going to start with, no, it's, actually, it's basically, this is controlled by if n is greater than, no, if if n is greater than or equal to k, length of k, length of k is obviously 4 because that's all of our known set. So if it's greater than length of k, which is 4, then do this. So in that case, so otherwise we just skip this. Now if it's less than length of k, then we are just substringing it, and if it's greater than k, we just start from letter 6 and go to 21 minus n. 21 minus n. No, because oh fuck. N plus. So so there has to be. It's f. Because what I need to do is there's like this little subdivision inside it because I need to consume. So it's only if it's f. So if I had 26. No, that's right actually. So it's going to be f plus. Let's do this again. So take this out. And this is going to be, let's just do f plus 1 because I know what that is. F plus 1. Whoa. So, okay, so if we're greater than 4, then it's going to be I is starting at f. That means we're at f plus 1. That means we're at 6. That's it. Now, if we want, so if we put in 5, then 21 minus 5 is 16. This is oddly difficult. Oddly difficult. So if my input is now, say my input is 5, that's going to need a G. And to get a G, I need it to be 6. So that's correct. And it's going to go from 6 all the way to 21 minus n will be, sorry, I meant to do this, n. So it's going to be 21 minus n equals 16. And of course, we've already got 5 letters. Ah, this is it. Okay, so then if I do, that's correct, so cool. So now if I did n equals 26, then it's going to start from 6, and it'll be, no, it can't be 26, that's the thing. No, it can be 26. It has to minus, so this is what I've already done, it has to minus these. So if it's greater than that, it needs to minus, yes, that's right, minus f, or length of f, which is going to equal 21. N equals 26, then it's going to be 26 minus, so it can't be 21 minus n. It's minus f plus n. How about that? how about that? Because now it's always minus 5 plus 26 equals 21. And if I start from 6, I can't do 21. But I've pushed it up an index, maybe minus 1. Minus f plus n minus 1. So now addition then subtraction. Let's do that. Minus f plus n minus 1. So now let's just do it again for giggles. If I were to put in, let's do a green here. If I did to do 5, or n equals 5, then it's going to be minus 5 plus 5 equals 0. And we're going to start the loop from 6, and we're going to go all the way to all the way to 26. Why is this so hard? Oh man, I think I need to start again. Okay. Okay. Let me just see if, because I heard a doorbell, I don't know if it's for me or something. No, I don't think so. Okay. I feel like it's almost there. Minus f plus n minus 1. Okay. Focus, right. So we've got the original k set. That's not even important anymore. I've got to iterate from the num. So if I do, okay. So let's just put this into the code for a second. So this is correct. If n is greater than or equal to, if n is greater than or equal to, if n is greater than shell letters, and shell letters length is going to be 4. So if you put in 5, then we need to start adding after f. So let me just get rid of this stuff again. We know that's the case. Whew, okay. So yeah, okay, so we're going to start at least from, if n is greater than 4, so have to at least start from 5. Now this but it needs to start from 6. It needs to start from 6. So it's going to need to start from position f plus 1. It has to do that. Has to. And in the case of n equals 5, then I've got n to play with, and I've got the full range of alphabet. So it's got to be length of A minus F, which is the leftovers. It's going to be leftovers minus N. I think maybe I did this right actually, because yeah, maybe I just confused myself with this greater than thing. So if I did, okay, so because I can't go, so okay, so now if it's 21 minus, now if n comes in as 26, then this is still 21 minus 26, which isn't right. 26 means I need to do more. So it's basically, it's got to have this number in it, and it's got that number in it. It's 26 minus n. It can't be that. It just can't be. But 21 is what I need. So it's what's left of that. It's n minus 21. Because then it's 26 minus 21. That's not right either. What? Why am I struggling with this? I need it to be 21. It has to be 21. And I've got an n, so I've got 26 coming in. How do I get it down to 21? I need to minus f plus 1. Oh, I need to minus f. So 26 is the alphabet, minus f is this offset. But n is not even in it anymore. So then, so if n is n equals 26, and then if n equals 6, then if I minus f, then it's too small. It needs to grow. This is very, very bad. So it works for this one, only because it's a big number. But it needs to be a ratio of that number. Because if n equals 6, then this needs to be plus. Because I've got a lot of iteration. No, I haven't. If it's 6, I only need to do 1. Equals 1 iteration. One plus f. It's n equals 6 minus f plus 1, I suppose. That's right. Okay, so I'm freaking myself out here. Okay, let's just say that again. So n, if n is equal to 26, I need to get that to 21. So n is going to therefore n is going to equal n is equal to 20, so therefore it's going to equal n minus f. Now in this case that would mean it's going to have 21 loops, and then 21 plus f is our good stuff. Now if it's n equals if n equals 5, then it's only got one to do. So n therefore equals n minus f, which is going to equal 0. Now this is a problem because I need to at least go once. So if 0, then 1. So it's where it must not equal 0. Now if it's n equals 6, therefore it's 6 minus 5 equals 1. Therefore it must equal 2. So it's always plus 1. So it's n minus f plus 1. Let's do it again, because I'm still not sure. This is n equals f plus 1. So if n is equal to, or what, it's like the leftover basically. Whatever we call this, let's just put a thing, I don't know, like a t. So if n is equal to 7, then t is therefore equal to n minus n, 7, minus f, 2, plus 1 equals 3. Now, let's just do this one again because I'm not too sure about this one. So t is therefore equal to n, which is 26, minus f, which is 21, minus f is 21, plus 1 equals 22. Now 22 plus 6 is too much. So where have we gone wrong? So it works for everything here. So, okay. So this almost needs to start from the actual f, because then I can start, and then I can, okay, so this is now f, so it's going to be plus 5, so at least we're a little bit close. So let's do this again. So if n is equal to 26, then t is equal to, t is going to be this, t is equal to, oh okay, that's actually what I meant to do that for. So I will do the leftovers. Oh, a bit more difficult to draw that one. Leftovers is therefore equal to it's n minus 5. So it's 26 minus 5 minus 5 equals 21. And if I did 5 to 21, that's 26 iterations. That's still too much. Five to 21. 5 to 21. So okay, let's just take a gamble here. So maybe it's f n minus f minus 1. Let's just imagine that is the formula. So let's try n equals 5. Therefore, leftovers are therefore equal to 5 minus 5 equals 0, and that's going to be negative 1. Oh no, wait, f is index of f, yeah, okay. Yeah. Hmm. So where does this go wrong now? Because this wouldn't have been fine because it would have been 0, and this won't be fine because it needs minus 1. So this clearly doesn't work. And n26 minus f minus f. This is ridiculous. It's absolutely ridiculous. Let's try it again. It'll break one day. It'll make sense one day. N is equal to 26 if it's 26, and n is equal to 5. 5 is the first one where I need to start introducing stuff. So this must be, leftovers must be 21, and it must be 21. So therefore, it must be n minus f. Now, if it's 5, this must be equal to 1. Therefore, n minus f equals 0. Even then, it shouldn't be that, because it's got to be n minus 1. N is equal to n minus 1. So let's try it like that then. If n equals that, it's let's call this mu. I think it is, isn't it? No, n. That's it. V. Let's do a v. If n equals to v equals n minus 1. So v now is equal to 25. Now that means that the leftovers therefore equal, they must equal 20. That's correct. So therefore v minus 5 equals 0. Wait, 25 minus 5 equals 20. That's the one, right? Right, now let's try this. Oh, let me scroll down, will you? Let's do green. N equals 5. Therefore, v must equal n minus 1 if we're going to apply the same equation. So thus, v equals minus 1. Now, that means that this, with the same equation above, must equal 1. But v minus 5 is equal to negative 6. If n equals 5. 26 characters in total. Minus n. 26 minus 5 equals hang on. It's 5 minus the leftover. 26 minus 5 a minus a. 26 minus 5 is 21. 21 minus 21 a minus 1. So 26 minus 5 is 21, and then minus 20 equals 1. And what's the formula here? So we've got now, the formula is now, that's length of alphabet minus f minus equals a, minus j equals j, and then j minus j minus 1 j minus j minus n. So if j is so if n is okay, actually this is something interesting. So now if we've got okay, we are so close to something here. So if I were to put in 26, so n equals 26, we go, so it's going to be length of the alphabet minus f equals, so j is equal to length of alphabet minus f, which is equal to 21, and then (21) minus 26. Wait, no, that's not right. So it's length. So it's j minus j minus 1. That's it. Equals 21 minus 20 equals 1. 21 minus 20 equals 1. Now, if therefore, if n is 26, then it'll be n, no, t, or this this one will be equal to n minus, let's call this x, n minus x equals 20. My goodness. This is ridiculous. We have a k-set, and we want to append. So this is 1 to 4, just deals with slicing that up. If we go to 5, then we need, so we need A5. If we need 6, which would be G, H, this needs to be A6, I, A7. To get 5, we have 26 in the alphabet minus F. We've got 20 minus 1 for the index equals 25 minus F equals 25 minus F equals 20. So that deals with that. Now we've got 6. It's 26 minus I need 5 here, so I need to make this from 5 to 5. Must always run once. (25 minus 5). So this is alphabet. Why did I do minus 1? This is the alphabet minus the alphabet minus n. 26 minus n. 26 minus 5 equals 21. I've never pushed myself to do this before. Interesting. 26 minus 5 equals 21. Okay. So 26 minus 5 equals 21. This is the alphabet. This is the F. This is the leftovers. 21. Okay, but we have a problem. Because this is wrong in terms of index. And that's because we counted the alphabet. So let's just do let's just stick with this 26 minus 1. There it is. Minus 5 equals 20. So that's going to give us 20. So it's going to be 26 minus 20, or 20. Yeah, alphabet minus F. So then it's going to be this J minus leftover equals 26 minus 1, 25 minus 5 is 20. 20 minus 20 equals 0. Then, where's n in here? So that was for 5. Now for 6. Yeah, we need to put the n's in here. 0 plus n. So I've already done this. Yeah, otherwise... the amount of letters to traverse is going to be the length of the alphabet minus 1 minus the index of letter F that's what I've got, which is going to equal 20. I just have to keep saying it to myself, so weird. How can I draw this? How can I get this to understand, make me understand it? Let me also do a blood test. 1 second. How can we visualize it differently is the question. Like I'm just hitting it with the same piece of paper. I need a hammer instead. A little bit high. Let me do an injection. Had like really unpredictable food because I had Thai meal and then a pizza straight after. I was just feeling hungry still. Let's go for a small injection. I want to make sure that at least whilst doing this I feel like I'm learning something, and I don't feel like it feels pathetic at the moment, which is really annoying me. I liked this though, because actually at this point let me just try and organize it better. Make it look a bit more sexy. So K is equal to, let's draw a grey line maybe. This is equal to 1 to 4 on the index, or so 0, 0 to 3. No. This accounts for 1 to 4 on the input. N for the input is equal to 1 to 4, and that will cover this. Okay. So the next part is if n equals 5, 6, 7, 25, 26. Okay. Maybe this will help. So for 5, I need, it's going to be this integral thing. A for 5 I need the 6th letter. For 6 I need the 7th letter. For 7 I need the 8th letter. 25, I need the 26th letter. Ah, no, I need 1 minus. So the index is not that, it's 1 minus. So it's going to be 4. This will give me... It said it won't. It just won't. If I put in 5, it does need to be the 6th letter. It does need to be that, it does need to be that. And it does need to be the 26th. But there isn't 26 letters in the alphabet. So what have I done wrong? Where have I gone wrong here? If I put in 5, it's not, the 5 does not correlate. 5 is the index that I need to go, so it's, but I've already got F. If I go to 25, I want the 25th, I want the 24th. And 25, I want the 25th. So where have I gone wrong? For the 5th, if I put 5 in, I want G. So this is all the way up to F. If I put number 5 in, I want 6 to get G. H. I. This is where this is where I'm going wrong. Y. Z. So, how does that change? It can't change. If F is the 5th, and I want the 5, if I put in 26, I need to like, it needs to be, hang on a second. It's going to be length of K. Minus length of A. So this is 26, 4, minus 26. Equals 2. And it's going to be, therefore, I, then therefore it's always adding 2 on. So if this was, if I is, if I start my loop from, it has to be started from 5 or 6. So this has to be 27. It's going to be minus 2. This needs to be 27 minus, let's call this A, let's call this X, minus X equals, so it's 25. And if I need 20, I've got 25 here, 26 minus 2, 25, 24. Now if I've got 6 here, if I go back 2, what? I'm using the wrong array. Somewhere I'm using the wrong array. N equals 1 to 4. Fine. For 5, I need the 6th element. I do. And for this, I definitely need for for 25. I need the 24th element. Where am I going wrong? With this, I need the 25th element. And for G, I need the 6th element. It's because these are not equivalent. This is the problem. These are not equivalent. But if I'm gonna have to do it. I'm just gonna have to do it because I'm just wasting time here. Let me just draw the whole fucking line. Let me just do it. 8, 9, 10, 11, 12, 13, 14, 15. I can't believe I'm having to do this. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. The problem is my brain is not doing what it's supposed to be doing here. K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Because 5 is G. I see how I can fix this, but because I just add two, I offset the index by 2. But I'm trying to get my head to understand it. Trying to get my head to understand it. It's because if we did it, it would be A is 0, B is 1, C is 2, E is 3, F is 4. It's not. Jesus Christ, can't I do the alphabet now? E, F. Can't even do the alphabet now. You see something's wrong. Yeah. Now, that means, so I don't care about these. These mean nothing to me. So removed from the alphabet, great. But the alphabet is 26 characters and we need to get to this one. So it's A minus F. If I minus 5, 26 minus 5, I get 21. Right, 1, 2, 3, 4, 5. Now, I'm so close to this. I'm so close. It's so ridiculous. The problem is the numbers I'm using for the input matching up to that offset. The iteration though is still 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I want to iterate 20 times. So 26 equals 20 times, and 5 equals 1 time. So I need to start my iteration from 1, and it needs to go to 20, 26. And then for this, it needs to start at 1, but it just needs to go to 2. And for the 20, start at 1, but go to the 20, need to go to 1, from 1 to 21. For 26, I need to go from 1 to 24. One day, people will look back on this and think, like, it's incredible how my brain is failing me so badly here. I'm also kind of having a breakdown at the moment. Okay. Okay. I was trying to shut up for a sec to let my brain rest a bit. I think I'd like to run these loops because I can't bother to work it out, but maybe I can. This will work because we start from 5. I is less than 5 plus 1, 6. It's going to run once, right? In this case, n is bigger, so you start at 5, and while I is less than 22, I plus plus. Now, if that happens, I is going to 5, so it's going to be I plus 1, and you're going to get 6 through to 20, 6 through to 21, because it's not going to get to 22. Now, 21 take away 6 is 15. 15 plus 5. I've done this wrong. This isn't right. So, I mean that's actually, that is correct, isn't it? So I think I'm going to put this in. I think I might have thought of it in a different way, and that might have helped. So in this case, it's going to be the amount of letters to traverse. So don't need that. I want to do, we start from index of letter, and we go to length of the alphabet. No, we go to n plus 1. And so now it'll just be current index plus 1. So this 21, it's not length of the alphabet I did n, but it's 5. It's like, if it's 5, then 6 is fine, but if it's 26, then it has to be 24. So 5 must become 6, 5 must become 6, and 26 must become 24. I think this is my problem. Like, I don't understand that. And that's a very basic thing, and I'm really having problems with this, and I'm happy to share this because I think maybe other people do stupid things like this as well. Maybe not. But it is interesting why I can't figure it out. Something's not building in my brain right. Um, Well, actually, yeah. This needs to map 25. Sorry. You see how that's strange? Because element 5, and if we start from 5, we have to plus 1 to get that 6. And we want to only iterate over the remainder of the alphabet. So it has to be that number, and it has to be the 26 in there. And this has to be the remainder, because for 26 we need to do from 5 to 21 iterations. And for 5 we need to do, for 6 we need to do I don't think it matters that there's 4, because it's 5 is literally pointed to the letter F, but we don't care about that. We care about it's the 5th of our set. And if it's the 5th of our set, then it's the 6th of the alphabet set. And if it's the 26th of our set, then it's the 25th of the alphabet set. No, that didn't help. That did not help at all. How else can I imagine this? Let's get rid of this again. This is the key problem. That is the key problem. We start from 5. We plus 1. If we start from 5, but 5 relates to 6. It's like there needs to be a mapping. So is this not? It doesn't have to be a mapping. Even though we have 4, it doesn't matter. It does not matter. It's just for every element it matters. Because I'm just appending to this. But it matters the switch from 5 being the 6th letter. 5 being the 6th letter. And it matters for 26 being the 25th letter. But where's the magic number that's going to compress it? Because we've got 5 must be 6, but how do we get that to 6? Well, we've got n equals 5, we've got f equals 5. Maybe we do the mapping here. So, no, I can't do that because maybe it's how many off are we from the actual letter? Well, we are 1 off from the letter. So f is like 1 off from the letter. And we are it's 5, and we're on 4. 5, we are -1 after the letter, because 5 is F, so we're out by 1. Now, if we've got 5, we put that in. We have 1 out, so we need to do N plus F. And if we are 26, we are still 1 out. So it's going to be N. If we put 26 in, it needs to be 25. And if we put 5 in, it needs to be 5. Oh, man, that doesn't make sense to me. I need someone's help. Like, this is ridiculous. This is ridiculous. If I were to draw a graph, maybe. Yeah, let's draw a graph. Desmos. Let's draw a graph. So I is equal from 5 to 25. 625. X equals and then y equals because I was thinking, let me just try and think about this. So I want to know what the mappings are. So x equals y equals y equals oh, I don't really know what I'm doing now. Don't really know what I'm doing. If I was to draw, this is the offset, so for the alphabet letter F, so no, for 5 we want 6, so for 26 we want 25. This doesn't help me. I wonder if there is a way of drawing the graph though. It almost feels like the reason I can't draw the graph is because I don't understand the problem. I'm going to enjoy this after this. This is going to be such a victory. Wow, this is crazy. Why is it that 5 maps to 6, but 26 maps to 25? It's because our alphabet is 25. This does it just mean that I can't go up that high? Just stop it. So if it was just stopping at that, it would be whatever you put in minus. But if I put in 5, I can't minus anything. I have to plus something. Or I don't have to plus something, but I can do. Yeah, no, I have to plus something. Yeah, I do have to do that. N equals 0 to n equals 1. N equals 0 to n equals 21. Because we've already got 5 in the bank. Yeah. So so how do I get this? It's gonna be 26 minus 5. And this is gonna be it's gonna be 5 minus 5. Where 5 is the alphabet letters. So it's going to be from 0 plus 1, and this will be from 0 to 22. And if I do that, it's going to be F, so it'll be 1, 2, 3. If I do that, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's to be plus 1. That can't be plus 1. There's something special about it being 4 and 26, so that's where my 2's coming from. I don't think I understand the problem enough here. If I make an array of letters, rather than... maybe that's what I do. I just... It's incredible not to understand that fully. But I suppose if I were to just make a set from, G to Z, then N equals 5 goes here. So 5 H I J K L M N O P Q R S T U V W X Y Z 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24. So this is going to be 24 elements. So you put in 5 and I just strip away. So it's going to be N minus 5. Then it's going to be 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19. Oh man, this is creeping me out now. This is creeping me out. Oh, that's interesting. I wonder if I just make a quick table. See HTML editor. Or maybe JS Fiddle. It's always a good one. If I just do that quickly. So if I go yeah, A through to Z. Yep. Okay. Got a few mistakes here. Whoops. Very strange how it does that. I think we got it now. Maybe this one. Okay. So that's our table. And let's give it a little border. Or is it borders? Pixels, something like that. Give table border. Give table border HTML. Border equals 1. Okay. Cool. Okay. And the next row, let me put this into Visual Code for a second. So this one I want one, no, I want 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 18, 19, 20, 1, 22, 23, 24, 25, 26. Okay. Okay. And then for this one I want let's have one more of this as well. Let's call this alpha. So letters, index of letters, index of index of shells. So item 5 will be, actually let me just put that into the editor, let's see what happens. So F will be, let me see, oh crap, that sucks. C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So hopefully that fixes that. Okay, and so F in this case is going to be, well, G is going to be 5. So G is going to be 5. So that's going to all go 1, 2, 3, 4. Wait. F is 5. And if I put in 5, I want G. So I put in 5, I want G. X, 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 X. Let me just see how that looks. If I put in 5, I want G. So I need another X, and I need to take so if I put in 5, I want G, so I need 24. To iterate over. Interesting. Here's a dilemma as well. No. No, that's fine. What was our keys again? S, P, D, F. I'm going to get to P again, but that's almost irrelevant though. I now just want to solve this goddamn problem, right? So it's just irrelevant. So if that's the case, then I just need 24, so it's going to be 26 or 25, 26 minus 1, 2, 3, 4, 5, 6. 26 minus 6. Where's the 6 come from? 6 comes from the offset of f, which is f plus 1. 26 comes from offset of 26 f minus 1. Oh, that's weird. Did I just change my... Yeah. Oh, and I got insert on. F minus 1. Hang on. So, if I want this to be G, then I need 26 minus 6. Minus 6. 26, 6 comes from F plus 1. One, two, three, four, five, six. Length of... Oh my god. Is that what I was doing all the time? There's 6, not 5. That's the index. Was that the problem? Let me just go back to my things here. If I start with my K set, and I do my integral, and I want to start from 5, and I want to go up to but I want to start from 6. So 25 minus 6. It's 19. No, because there's 26. 26 minus 6 equals 20. And it's going to go from... So if my n is now equal to 5, then I want to go 5 to 5, 5 to 5 plus 1. And if my n is 26, I want to go from 5, I want to go from 20 to 20. 5 to 20. That's 15. I want to go from... No, I don't want to go from 5. I want to go from 0 to 20. But the index will be I plus 6. Or f plus 1. So now if I want to go to, if I put 5 in, I want to go from 0 to 1. And if I put 26 in, I want to go from 26 minus 6. -6 comes from F, and this is the alphabet, and that's what's left. So it's going to be 20 . I'm going to figure this out in a sec. I'm going to have to do another session because I need to go to the toilet and stuff. I think we'll be back in about 30 minutes, maybe. So I think I'm getting there. I think my brain's slowly reworking, slowly rewiring. This really is a stupid thing. I just it says a lot about my current situation. Actually, I think probably a bit overworked. I think that's might what it be. Might be what it is. Yeah, give me 30 minutes. I'll be back, and we'll see how we get on. Speak to you later.